In this video, I'd like to talk about the math question of the day for February 18th, 2023. And this problem asks us to divide using either long division or synthetic division, where we have this ratio of two different polynomials. So to answer a question like this, you do need to have a solid understanding of Algebra 2, particularly dealing with quotients of polynomials. So at this point, go ahead and pause the video, see if you can work through this on your own, and when you're ready, we can go through this together. Now, assuming that you have attempted the problem, we can start working through this together. And if you do have suggestions for future questions of the day, feel free to leave that as a comment. Now, with this problem, we can either use long division or synthetic division, and they are similar and will arrive at the same answer, but they are slightly different methods. Let's start with long division, and we can come back to synthetic division at the end. So with long division of polynomials, it works very similar to long division of real numbers. We put the number or the expression that we're dividing into inside this box here, this long division box. And let me quickly rewrite this neater. And the number that we are dividing by, or the expression that we're dividing by, will go on the outside of this long division box. And just like with real numbers, let's say we have 3 going into 783. We ask how many times does 3 go into the first digit? It goes in twice. We multiply and subtract to find that remainder, and then we bring down the next number and we repeat the process. 3 goes in 18 6 times. We multiply, find that remainder. We subtract, bring down the next digit, and 3 goes into 3 once, and there's no remainder here. And like I mentioned, it works very similarly for polynomial division, but we're really just focused on this highest power term in the expression that we're dividing by. And we rephrase the question a little bit differently. We ask, what would we multiply this by to get 3m cubed? Excuse me, let me rewrite this as a cube. And if we multiply m by 3m squared, let me use a different color for that. But multiplying it by 3m squared, when we do that, we can find the remainder. 3m squared times m is just 3m cubed. And 3m squared times by 9 would give us 27m squared. And now we subtract to find that remainder. And if you're doing this correctly, these first terms always match up and you will get 0. And here we have 18m squared minus this entire expression, so we are distributing this negative, meaning we have 18m squared minus 27m squared, which would be minus 9m squared. And then we bring down the next number, this minus 74m, and we repeat the process. So from here we ask, what do we multiply m by to get minus 9m squared? We can multiply by minus 9m, and when we do that, we get minus 9m squared, and 9 times by negative 9m would give us minus 81m. We subtract now, and remember we're subtracting this entire expression, so you have to distribute that negative. The first terms here cancel out, that's just 0, and we get minus 74m plus 81m, which is 7m, and we bring down the 63, and we repeat this process once more. We multiply m by 7 to get 7m. Now we actually carry out that multiplication. We get 7m, and 9 times 7 is 63. We subtract to find that remainder, and in this case, we have no remainder. If we did get a remainder, let's say it was something like m plus 1, then that would go over the divisor here, m plus 1 over m plus 9. We would have a fraction at the end. But in this case, our remainder was 0, so we don't have to worry about that. And this right here should be our final answer after carrying out this division. Now to check this, and I will leave this as an exercise, you can take your quotient here and multiply it by the number that you divided by. So if we multiply 3m squared minus 9m plus 7 multiplied by m plus 9, we should get back this polynomial in the numerator. And I encourage you to actually check that, since it's very easy to make an arithmetic mistake in this long division. But when you do check this by actually multiplying it out, you will get back this numerator, meaning that you can feel confident that this is the correct answer. Now, considering synthetic division, like I mentioned, it's very similar, but we essentially get rid of all the variables. And the general idea is we have a little box, and in this box we put the number that makes this expression equal 0. So in this case, -9. Since -9, this is actually one of the zeros of the polynomial function. Or at least we think it is, and when we check it with synthetic division, if we get 0 for the remainder at the end, then we know that this is one of the zeros. And instead of putting in the entire numerator, we just put the coefficients in. So 3, 18, minus 74, and positive 63. If you want, you can put in columns here to separate these. And now the first step, we bring the 3 down, and then we multiply by the 0 here. 3 times -9, that's -27. And instead of subtracting to find a remainder, we add when doing synthetic division. So this gives us -9. We multiply again, we get positive 81. We add these, we get 7. We multiply again, we get minus 63. And when adding these, you get 0. And you might notice a lot of these same numbers that we ended up with in long division, since, like I mentioned, they are very similar and come from the same basic principles. And once we carry out synthetic division, if we end up with a 0 for this remainder part, then our quotient here of these two polynomials will have these coefficients, and the degree will be 1 less. Meaning that instead of a cubic polynomial like we started with, this would be a quadratic. We get 3m squared minus 9m plus 7. So from synthetic division, this is what we think is our quotient of these two polynomials, and you can see we got the same answer we got with long division. So like I mentioned with this problem, you can either use long division or synthetic division. Personally, long division is a bit more intuitive to me, so I tend to do this method. But as you can see, synthetic division tends to be a little bit quicker because it doesn't have all these variables. It just has the coefficients on the variables, so it's a lot less writing. So it's your choice which one you actually want to use, but the nice thing about these problems is that they are fairly straightforward to check.